So I am writing a compiler for a small imperative programming language called Elna that is on the screen now. And today I'm going to look into expressions and into unary expressions and try to allow more complex expressions. And for that, we firstly look into the rec file and create an additional stage so we can test our changes. The compiler is self-hosted, so each stage of the compiler adds new features, and the previous stage compiles the next stage, and the next stage the stage after it. And we are on the stage 18, and we need to replace this 18 with 19 and this 17 with 18, and it will copy the stage. Or probably not. I think that I have to create the stage manually at first, but after that we can use this task to update the latest stage. So we go into the boot directory and create, or just copy the stage 18 into the stage 19. It actually should be enough. We have to update the Ninja build file. I think I can do it with build Ninja, and then Ninja should pick up the stage automatically. But it does not want. So, or probably Rake didn't update the Ninja file. If I remove it first and then generate one again, then I can call Ninja again, and it still doesn't want to do anything. So let us look in the rec file. The default is hard-coded to the stage 18. This is a loop, I think, so let us rewrite it a bit, and we just put a new line here. Default build valid stage 19cl, and then we enter the string, and instead of 19cl I think that we can write stages last or something like this. Exactly, so we have a stages array here, and the last stage is actually the stage we need. So let us replace it with stages last and see what happens. We remove the file again, then generate it, and then look into the generated file, and the default statement looks fine now, and we should be able to call Ninja now, and it compiles the 19th stage. Okay. Let us open actually this stage in 1/2. So put stage 19 would it be, and Elna. We just define test procedure as always, calling it f with one argument. We probably even do not need arguments. Just let us define a procedure, and this procedure will define a variable v1 of type but. It will define v2 of type pointer to a word, and it will define v3 of type pointer to pointer to a word. Then we write begin and test whether it lists the type expression with multiple levels of pointers can be compiled. So for that we call Ninja again, and I copy the command so I can just paste it next time. Okay, that seems to be fine. I actually use tabs everywhere else, and I just assign some value to the variable v1. Let it be 5, I would say. That should be fine. Then in v2 we save a pointer to v1, and in v3 we save a pointer to v2. That should be fine as well. But what won't probably work is the access of the pointer inside a pointer. So if I say that I want to dereference v3 one time, then it should compile. But if I dereference it twice, it probably won't. Okay, it does compile. Then we try to use this procedure. I actually want to print it or do something with it, but we print the assembly into standard outputs, so I can't just print it into the code because it will break the output. I actually can assign or we make it here inside the procedure itself, so we do not return it but pass it to a printf, and we just create a comment that we print an integer. The procedure is already called and it should print a comment at the start. So let us open the generated assembly. That should be actually validation of stage 19. And we need the assembly file. Okay, it can definitely output the thing, but it produces garbage as far as I can see, because I tell it to print an integer, and we have v1 to v2 and v3, so it does actually looks correct to me. The result is wrong. Would be interesting to see what it actually prints. Let us print it as a pointer, and we will print the other pointers too, so that we can check the address, for example the 2 and the 3 as is. Oops. Oh, I should print here v1, of course, but we cannot already see the problem. So the tree isn't dereferenced, but it produces an address instead of the value at this address. So let us recompile it. Exactly, in the first case we print 5, in the second case we print the address saved in v2, which will be the address of v1, and in the third value we see basically the same address. Let us try to see what happens. So the expressions we are interested in are these designator expressions, and we probably need this LNTIC designator. The problem here is actually that I just keep the same address, I don't dereference it. So once again to the assembly output. V1 is 5, that is fine. And it just always prints the address, it doesn't dereference it at all, it prints the address of V1 basically, yes. A similar case would be actually field access expressions, because it also allows to reference some memory in a bigger type. But I actually do not use it too. I wonder, so is address is pointed to a boolean, and the designator should set this pointer. I wonder if I have any cases where the value of is address is 1. I should have some, but let us check it quickly. Recognized value is 1. Fair enough. We probably need a different assembly output, because it is the output of the previous stage. So we actually want to look at build boot stage 18CL, and it has two instances where the is address is true. I wonder whether it has something to do with this F procedure. Let us remove it. So it is generated once somewhere. and I really use it for an assignment, and I have a suspicion that it doesn't work. So if I remove this line, will it change something? No. So we use it once, but the code isn't called, therefore it doesn't break anything, I think. What is actually the usage? Do we need this at all? So it is the RTL stage and binary operands, and it checks whether the left side is generated without any. Yeah, it does actually make it checks whether the left side is saved in some temporary register or whether it is an immediate value. Let us keep it as it is. I'm pretty sure I had, yes. So if it is already an address and we have the reference expression, then we want to add an address and add it to the list of instructions. So we actually need to append an instruction to this first instruction. I know that this is bad, but I will just reuse existing variables. I definitely use here something to create additional instructions. For example, here I do not use this variable before, so we can just say that we want to create an additional instruction. This is not a net instruction, but a load instruction. For this instruction, so how do we generate load instruction? LNTAC operator load. For example, here we generate one. It has two operands that make sense. And I think that the second operand is the target. What is it? This is unary expression. And operand type is what is passed to this procedure. And we save, no, the first operand is the address. I set them later. So the second one, we do not need this case. Then I do not know whether I can just use the same operands, probably not. but we can try. So I just use the same stuff. I say that this is still an address. I can actually just set it only if it is not set already. So let us add an add condition, and we set an address nor in this case. And I would say that we can try to compile this. But first I need to append this last instruction to the list. So we say that first instruction is first instruction plus last instruction. Okay, so where we can check it, I edited the 18th stage. That means that that if the 19th stage compiles itself, I actually would expect that it is visible here. Of course not. So let us, we need to go to this procedure, and what we are going to do, we copy this stuff here and we go to the rake file, and we say that after copying the stage, write this chunk of code to the end of the newly copied stage. So we need to indent it a bit. Okay. So we can just say that we write this stuff Oh, this is the wrong end, I think. Okay. Now what we can basically do, we can say rake convert, and I have an error somewhere. What actually does rake say? Syntax errors. Oh, yeah, that makes sense. So convert. Okay. If I open the stage 19 now, I will see that it is something that it is pretty broken. So we can add a new line here. And the rest actually looks fine. Oh, because I'm putting this one here. We just need to escape it, I think. So once again, yeah, looks definitely better. And we still need to call this procedure. This place in the main function was actually pretty fine. Let us just look for this line in the input. So here we will say that if we see this if line include, I would say, this chunk of code, then before we write this line, we add a call to f with a new line and with a tab at the beginning. So now we do rake convert again, and we visit the stage, and the call is here. And now we can call Ninja. And I probably need the validation stage. Stage 18 CLS. And now it does what it should. So we fixed it. Let us go to the stage 18 again. We need to remove debug statements if I added something. So we go back to the stage, not build, boot, stage 18 CL. Elna. Okay. This is the procedure. Its address looks fine. So it actually looks fine, I think. The calls are not interesting for us yet, and here we just say that this is not a designator expression but a simple expression, so like a variable expression. Let us test it with other types than pointers, for example with records, because these two things are needed to handle the arrays properly. My actual records do not have nested records inside them, so that I can access more than one level of fields, and I'm trying to go in the direction where I can support more complex records. And we will go to the stage 19 again, and here we will define a record. We will call it R1 and say that it is a record with field 1 of type bird and field 2 of the same type, and then we will add a record R2 where we have field 1 of type bird, and then we have field, not field 1, let us call it field 3, field 4 of type R1, and then field 5 of type bird. So this is the records that we want to have. I'm going to get a pointer to this record in my procedure. So variable r of type r2, pointer to r2, and what we actually want, we want to print an integer here again. Let us keep this statement at first. I actually want to dereference the R. Then I want to access the field 2, and in field 2 I want to access field, it wasn't field 2, it was, what was it, field 5, I think, field 4. So R2, field 4, R2 is the type, field 4, and then I want to access the field 1. What can we do with it? Probably assign a value, I would say. Let us use 5 again. And it crashes. And this is exactly what I meant. So we probably do not, or we can assign the value to one of the variables so that we can see whether the error is in the assignment or in the expression itself. So we can say that v1 is, for example, actually the same thing, and then compile it once again. Okay, what would happen if I assign field 3 to it? The same. So the problem is probably somewhere else. Stage 19CL R2. I get an R2 pointer. And it has some fields. If I remove it, oh, of course I cannot access it, because I pass garbage to it. This is a bit stupid. So let us add R2 be a variable. For example, instead of v3, and we are going to allocate memory for it. So we just call malloc with the size of R2. Okay, this one works. This is 7. This is not interesting because I know that it works. What I do not know whether this one would work. Okay, at least it compiles. If I assign a value to it, for example 5, will it compile? Yes, it does. And now I suppose that we can print it. So we remove these 2 pointers. I can probably just output 2 fields. So we set also the second field to 7, let us say, and we will just print the field for field 1 and R field for field 2 and see what happens. Okay, it actually works as expected. There can be also more complex cases, for example, with pointer fields and such. but I do not want to test any case. I think that we will go with how it is and fix problems just on the way if we encounter something. The change was actually pretty minimal. I even think that we can port it to the stage 17 so that we do not need a new stage for this feature, and it actually will also fix this bug with double dereference expression. So let us exit the stage. We do not need the stage 19. So what we see if we look into the changes, this is actually only this block in the dereference expression. I'm just going to open this file and go to the designator expression, TIC designator, and I'll just copy this stuff here and then open the previous stage 17 and replace this is address with this if block, and that should be it. Now what am I doing? Build. Oh. So, and another thing that I want to have are arrays. And we go to the stage 19 to this test records, and we will replace this field with an array. Let us be an array of 3 words, and we actually do not need the both types, just the R1. The fields can be renamed then, and I still need to allocate space for this thing. I just need only one variable, and we want to access an array element. This is not implemented at all as far as I remember, so we will begin probably and continue later. Yeah. We need to dereference this thing, then access a field. This is field 2, and then access an element at this offset. I do not want to assign it, but I do not want to assign to it, but I want to get the value first. So we assign basically this thing to the v1. We can remove this stuff from here. The value will be garbage first, but I do not care for now. And here we will just print v1. Okay, and it crashes pretty fast, pretty early. So the first place where we encounter these array expressions is the parser, and it will be probably parser designator, something like this. And I have a head here. This is the dereferencing field access, and with this one, left parent is a procedure call. It is not exactly a designator expression, but syntactically it looks similar because we have parents not on the left side but on the right side, the same as the head for the dereference expression, similar. So we just need to add here in another case and check whether the token kind is an Alexa kind left square, is it called, I think. If this is the case, then we say that simple expression is Elena parser array access, I would say field access expression, array access expression. And we pass the simple. What is the simple expression? The simple expression is the base. So it is the thing that we are dereferencing probably. Okay. So, and we already passed them in a loop. Exactly. I then go back to this designator loop. Okay, we pass a simple expression to it, and we go to the Elena parser designator loop. Access expression should actually be pretty similar to the field access, but in the field access we access named offsets. So we assign a field name to each offset, and in an array we access basically by a numeric index. Therefore, let us look at this Elena parser field access expression and see what it does. Interesting. So we just define, I'm going to close this one. We just define a new procedure. Of course, not the field access, but array access expression, and it takes the aggregate. So in our case, it will be the array, and its type of is of course not a word, but let it be. What is actually the type? We will look it up in a second, so that I just finish it. And at first I just return nil. Okay, the output is already different. I wonder, yeah, we need at least to skip the tokens. So we encountered a square bracket. That means that we can skip it. This would be the first step. Then we read the next token. We need to define a variable for it, being token kind, and we have multiple statements. So we write begin, we skip a token, then we read the next token, read token kind, and this one is the index. We skip the index. We skip the index. And then we read and skip the closing square bracket. Okay. Let us generate just some value, just for test. So we define a result variable, and it won't be a field access expression, but just an integer literal, and we just try to generate 0. So I do not know what was the tree kind. So this is Elna tree kind, and this is the first one, integer literal. Type decoration is 0. Aggregate isn't available. I think the only field that matters is actually just the value field, and we return this result. Left square is probably fine as well. Alexa kind, left parent, correct size simple expression go to what is actually this integer literal? Integer literal, so it has kind, type, declaration, and value. That is actually fine. Where does it fails? It fails on linking the 18th stage. This is what happens if you do not have any proper error handling. But now it fails actually later, which could be fine. Because the 19th stage cannot actually compile it, and here we pass. I think that this is the command that fails, and we actually compile with the 18th stage. So it is a bit disappointing. And we return it. And I just assign it here and return it later. Okay, let us go to the rec file again. We want actually to we want actually to modify. So I'm going to keep this. I'm going to keep this test code, but I will generate the next stage a bit differently. We won't do it in the rake file, but instead we will just put the test code in the 18th stage, so it is just copied. That means that we need the 19th stage first. We can start with this function and copy it. here at the end, and then we need the test type as well. It would be this R1. Oh, I cannot have it here, of course, because the previous stage won't be able to compile it. Now I know why I did it in the rake file and not here. That makes perfectly sense. Yeah. So no, we do not do this way, but we want. Let us actually try to compile it after we fix the type name. So it would be this command. Okay, it still fails somewhere. We said that here we do not have any R1 or 2. We said that I open the rake file and I already do not have this code anymore, but it doesn't matter because it was pretty short. So we just add it again and say that in the current stage we output this epilogue and we print this function there. So, and we will just add 6 spaces in front of each line, or almost each line. So this is fine now. And the second thing, so we have a call here, and we can just say that if line includes let us just say current stage call to F with the tab a new line if line include this if compile then, and another condition I can write it with else if. So let us else if and the second condition would be we place where we put this R1 type. It's actually in the front of how can I find it? Can I put it into the beginning? No, but I can put it actually after the type. So let us do it similar. We print basically this record. So tab R1 record NTT field 1 is word and tab field 2 is 3 words and tab field 3 is a word, then new line tab and semicolon new line, and we are done. And this is actually pretty long. and the condition is that the current line is type. So if the current line is type, then we do it, but we write it as a normal condition because the variable value is too long. Let us call it record, I would say. And we put it, so I just copy it again and put it inside. And we just add a few spaces in front of it. Okay. We can put a line after it, and now we can call rate convert, and it will fail, of course. Oh, makes sense. And it still crashes. Let me look at the stage 19. So we have this procedure at the end, and we have the same problem. I have forgotten about it, so I had just to escape this stuff. Exactly, then we do rate convert again. And now we still get an error. So I have a variable r of type r1 fill 2, and I print it at the end. v1 is defined, r is defined as well, and we access fill 2, the second value in this field, and here I have a type r1. This is record, and it has 3 fields, which is actually fine. So we can just indent this type with one additional tab. Huh? Or it just probably skips the probably just skips the tabs. Yeah. Well, it actually doesn't matter. It should work, but it doesn't. To avoid other errors, we test it with a simple field and just see if this works, because it should work if the compiler isn't broken. So let us call Ninja now. Yeah, it doesn't seem to compile. So our problem is the array access. This is the rake file. We do not need it at first. We go to the stage 18, and somewhere I had this field access expression, and I would be interested to know if I have ELNA3 array type expression, but I think that this is pointer type expression, record, enumeration, field access expression. So I do not have array type expression is array type. We need array access expression. So we just define a new type here, somewhere under the field access expression, because they are pretty similar, and we call this one ELNA3 array access expression of type record. It has ELNA3 kind. It has type decoration of type ELNA type. Aggregate aggregate is the array, and the second thing is actually an index. So this is everything we need. Oh, now it compiles. So the type was missing. Where have I used it? Probably in a variable type. ELNA3 array type expression. As argument type. Okay. No, this is the wrong one. I need this ELNA3 array access expression. Exactly. It isn't used. This is kind of weird that it didn't work before, but well, probably some glitch in the build system. Where were we? We had this ELNA parser. What was it? Array access? No. Designator and ELNA parser array access expression. It gets an array. Oh, this is the reason it worked. I see. Yeah. Okay. Okay, I see. I do not allocate the result, do I? L03, and we set that for the time being we just generate a 0 instead of a proper value. And then it compiles. So I will leave it here. As the next step, we just replace this integer literal with the proper type, so array access expression, and then we catch it during the 3 address code generation and generate the proper code for it. Probably we can use at first also some stub instead of the real code, so just generate a constant or something like this for testing, but we can introduce the support for the array expression in each pass of the compiler, so we can understand it in the parser. Now then we will add it to the 3 address code and then to the register transfer language. But this is something for the next time, and today I will finish here.